Hello guys, how are you? All good? Okay, so we'll start a session. Before starting a session, what do we need to do? We just need to check our audio and video and post that yes, our session is on. Just give me a moment, let me just check it. It's perfectly fine. Just give me a moment, guys. Yes, guys, so let's start a session. All set? Everyone is here? Great. So now tell me. So what all expectations do you guys have regarding this chapter? Okay, tell me. Who are there in the class? Let's wait for people. Let them turn up. Then we will start our session. Okay. So let's start our session. That's me, your mathematics teacher Nishant Khanduja, and I graduated and post-graduated from IIT Bombay. My rank in IIT was 1256, in Air Triple it was 363, in Rajasthan pre-engineering test this rank was 4. I traded in US and Canadian markets for 2 years, and post that I started teaching, and it has been almost 8 years I have been teaching, guys. And one thing that is really close to my heart, that I always wanted to share my experience, my knowledge when I was whatever I gathered when I was preparing for IIT with my younger brothers, sisters all around India. I'm sorry, guys. So with the same thought, I ended up joining Unacademy. Yes, I ended up joining Unacademy, and there I joined Unacademy for their India's largest campaign. What is that? That is Let's Crack JEE. Yeah, Let's Crack JEE. Then I'm playing a very small part. I'm teaching you guys mathematics for IIT JEE so that you guys can feel comfortable while attempting the questions from this competitive examination. Now, if you want to study from me, so what you guys need to do? You guys need to first install Unacademy Learning App. The moment you install Unacademy Learning App, you need to go for two options. You can go for either of them. You will find first Plus subscription, and the one is the Iconic subscription. So in Plus subscription, the kind of benefits you're going to get, so we'll talk about them. The very first thing is you are going to attend daily live classes. So what are these daily live classes? So these daily live classes are not YouTube live classes. There you are going to interact with the educator. You can ask doubts. You can have your quiz session. You can also answer the polls conducted by the educators. So in a way, the kind of experience you're going to have is it's very much close to your offline classroom. You can also be a part of live tests and quizzes. You can evaluate your preparation. You can just, let's say if you feel like that there is a particular topic and you want to check, what sort of preparation have you got. You can just go to any live testing quizzes. You can just check your knowledge. You can also attend structured courses conducted by these top educators. So now what I mean to say is structured courses. What does that mean? So in structured courses, you get to have maximum knowledge in minimum time. That's what the benefit of attending a structured course. These structured courses have got educators, those who have gained the knowledge throughout their teaching hours, or maybe while studying. So this knowledge they just share in a few hours. So that's the benefit. That gives you an edge when you're competing for this sort of competitive examination. You can also have the access to all the recorded videos by these top educators. So wherever you feel like n number of times, you can watch these videos and you can revise your topic. Whereas in Iconic Subscription, apart from having all these benefits, you can also have personal mentor. So what this personal mentor is going to do, he would be guiding you. He would be guiding you throughout next 1 year or 2 years, depending upon your own subscription package what you buy. You can also have test analysis report, which would give you personalized feedback that would tell you how to improve the time management in the examination, how you can reduce your negative marking, how you can get better positive marks, how you should improve your examination approach. You also have the study planner. So this study planner would customize the study plan according to your own need, and it would also review your progress bi-weekly. So if at all you find any changes, those changes would be incorporated in the next study plan. So this is the benefit. So now if you just look at the Iconic Subscription, what it is like top quality content plus the guidance. When you have the content and the guidance, your best possible result is certain. So you can call it a goal-oriented subscription also. Okay. Now let's talk about how to subscribe these packages. Very first thing what you need to do is first install Unacademy Learning app. The moment you install it, go for these options. So let's talk about the time duration you have for plus subscription. You can have plus subscription for 1 month, 3 months, 6 months, 12 months and 24 months. I would request guys, if you're in 11th standard, go for this 2-year subscription. And if you're there in 12th or 13th, or maybe a dropper, then go for this 1-year subscription. Let's talk about the benefits you're going to have. See, the benefits are very simple. I'll tell you the reason why you should go for this 2 years package if you're there in 11th standard. The very first reason is, let's say if you're in 11th standard, so for you preparation is for 2 years. Now in these 2 years till the examination gets over, you would like to have the access of the application, because at the last moment you would like to revise, you would like to clear something, or maybe you would like to just practice mock test. So for all these things you need to have the access. Now just imagine if your access, now the subscription gets over before the examination and you're going to the examination hall, you would not feel confident because still you are doubtful about a few concepts. You didn't do your preparation to your capacity. So when you have all these doubts, these uncertainties, you don't feel confident. So that's why you should have the access till the examination gets over. First. Second is, it's very cost effective. Look at the price. What it is 2,000 rupees, 350 rupees per month. If you just look at per day wise, what it is 78 rupees per day. And if you look at per subject wise, what it is 26 rupees per day per subject. So that's what you need to pay. Now what sort of, look at the amount. This is a very nominal amount you're going to pay to top quality educators. And what it is for 2 years it is 56,000 rupees, and for 1 year it is what 38,500 rupees. Now, if you apply my code NK001, you would see the magic, and you would see that prices are being reduced by 10%. So for 1 year, it would become what, 34,650 rupees, whereas for 2 years, it would become what, 50,400 rupees. Now let's talk about the iconic subscription. So this iconic subscription is available for 6 months, 1 year, and 2 years. And the cost for 1 year would be what, 65,000 rupees. For 2 years, it is what, 1 lakh rupees. But if you apply my code NK001, you would find what, 10% off. And here the price would become what, 90,000 rupees for 2 years. And for 1 year, it would become what, 58,500 rupees. Here. Now, if you guys are looking for a suggestion, then I would say better you go for it ASAP. The reason is very simple, because the more time you'll have for your preparation, the better result you'll deliver. It's a very simple concept. There is no complicated logic behind this. Fine. So let's move ahead and start our class. Let's talk about limits definition. So what is limit first? So limit is like, let's say, what we do is, let's say there is a function. This is your y and this is your x. Now there is a specific value, let's say x is equal to a, and you want to check in the neighborhood of x is equal to a, that let's say if you are coming from right and if you are coming from left, where exactly you are heading to if you are just moving along the curve. So you can say if you are moving along the x-axis. What I mean to say is, I use different curve. This is curve I minus. So what I mean to say is, let's say if you are moving, let's take the neighborhood of x is equal to a. And now let's say you are moving from the right along the x-axis. When you are moving along the x-axis, you just want to check the function's behavior, where exactly it wants to be. So you would see that it is heading towards here. Similarly, for left hand side, you would see that the curve is heading towards here. Now let's take this width as h, and this is h, and this is what? This is also h. Now if you want to talk about the right hand element, this point will be what? This point will be a plus h, because it is on the right of a, whereas this point will be what? A minus h. Now you just wanted to check function's behavior either on the right or on the left. So this right one will be called what? This right one will be written as f of a plus h. This is the right one thing, and left one thing will be called what? F of a minus h. Here. Okay. Now let's check where exactly they would head if we try to come very close to a. For that, your h needs to go to 0. So let's do this. Let's put the limit where h is tending to 0. The moment you put limit h tends to 0, these two things are called right hand limit and left hand limit respectively. Here, so these are called your right hand limit or left hand limit. So this is one of the definition to understand what exactly the limit is. Now the other definition for limit is like this. Let's say there is a function and we call it limit, let's say L. This is our limit L. Now there is one epsilon. Just give me a moment, I'll just clear it out because it's not required actually. Yes. let's say this is your part, and for this, let's say let's say this is your x is equal to a. This is your x f of a plus h. Yes, we'll talk about that. Manas, just hang on. We'll talk about that. Don't worry. And this is a minus h. Okay. Now, let's say this difference is called epsilon. Now, for all epsilon greater than 0, there exists. Now, there exists. Now, if I feel like I can say there exists, let's say h greater than 0, such that for all x where this x is minus a, this will be what? This will be less than h. And this implies what? This implies your f of x minus the limit will always be less than epsilon. Now you would say, sir, what sort of language is this? I'll make you understand what it is. So what it tries to say is that, let's say your epsilon greater than 0 is there. Okay. Now for every epsilon greater than 0, if you take any value of the function which is at slightly more than a or slightly less than a, you would find that this relation holds true. That's what it means. Okay. Hope you guys have understood this. This is a very complicated definition that you would be studying when you will be there in first year of your college. Otherwise, this definition is perfect. You can just use this. Oh, I could see that as you guys can't read it. So what I'll do is I'll just write it once again. I'll just erase this. I'll write it here because I get that is behind my video. So there exists h greater than 0 such that for all x, now for all x is like this, x minus a lesser than h, and this implies what? Your mod of f of x minus your limit. This is what? This is lesser than epsilon. And here your L is what? Your L is limit x tends to a, f of x is equal to what? L. And that's your limit defined. So that's how they define. They say that if you just, there is epsilon which is more than 0, slightly more than 0. So for that there is an h defined in such a manner that either you go to the right or to the left of x is equal to a, you would find the difference of function and the limit, and that would be always less than epsilon. So that's what it means. Okay. Now let's move to our next thing. Now let's talk about the limit's existence. When exactly your limit would exist. So when your right hand limit and left hand limit, they both are equal and defined. They are equal and defined. Then only we say that limit exists. Okay. So this is a very basic thing. You always need to remember this. So what I mean to say is, let's say if you have two functions like this. So one function and it is showing like this. Now at this point, let's say this value is missing, but the limit, if you calculate the limit and the limit is coming here at this value, and your right hand limit are also coming at this value, and both are equal and both are giving you finite value, then it is what? Defined. Finite value, then it is defined. Clear? But your function is not defined at this value, at let's say x is equal to c. Function is not defined here, but your left hand and right hand part, they are Those limits are completely defined and they are giving you what? Finite value. Clear, Manas? Okay. Shall we move ahead? Manas, if you have understood this, just give me a thumbs up. Give me a thumbs up. So this is clear about limits existence. Okay. So we will move ahead and we'll be talking about other things. Now, what are these other things? So in other things, we'll be talking about properties. What sort of properties are we going to see? So let's say there are two functions and they both are written like this: addition or subtraction. X is tending to, let's say, A, and limit is applied to the addition or subtraction of these two functions. So what we can do is we can separately apply a limit on these functions and then we can do the binary operation. If we are required to add, then we'll add. If we are required to subtract, then we will subtract. Clear? Same thing goes for this also. If multiplication is there, so we can again apply the limit on both the functions separately and then we can multiply them later on. Clear? Even for division also, but in division just make sure that your g of x is defined. It is not equal to 0 actually. Very first thing. G of x, make sure your g of x, your limit x tends to a, g of x is not equal to 0. Just remember this fact. Even for your exponent also, if let's say your exponent, if you are getting a function like this where you are having one function of x in exponent, you can again apply the limit to the base separately and to the exponent separately. Then you can solve easily. Okay, so these are a few properties which I want you guys to just remember whenever you are solving limits question. Clear? Is it clear with everyone? If it is clear, just give me a thumbs up. Manas, whosoever is there in the class, I request you guys to just give me a thumbs up. Manas, are you there? Or Siddharth? I guess no one is around, so it's fine. Let's move ahead. Let's talk about indeterminate form. Now, what is this indeterminate forms? So, in indeterminate forms, the very common form is what? 0 by 0. And the second very common form is infinity by infinity. Now, apart from that, there are 5 more indeterminate forms. Those are 0 into infinity, infinity minus infinity. Then we have exponent forms, 1 raised to infinity, 0 raised to 0, and infinity raised to. So overall 7 indeterminate forms are there. Now these values can't be determined actually. That's why these are called indeterminate forms. Now if you just look at apart from these two, all the other terms, they can be simplified into what? 0 by 0 form. Even your infinity upon infinity also, this can be simplified into 0 upon 0. Now you would say how? I'll tell you the issue. So you would be writing infinity as what? 1 upon 0, correct? So see, 1 upon 0 upon 1 upon 0, this would become what? 0 upon 0. Even your infinity, 0 into infinity can become what? 0 upon 0. Even for your infinity minus infinity, if you take the LCM 0, 0 minus 0 becomes 0. And for these exponent indeterminate form, what you need to do? To convert them into 0 by 0 form, you need to take what? you need to take log first. You need to take log. Then only you can convert this into what? 0 upon 0 form. Okay, just remember this. This is a very important thing. And these information, see the way I am converting every form to 0 by 0, you should know how to convert every form to 0 by 0. Now why I am emphasizing on this? Because many questions are there, when you want to use L'Hopital rule. L'Hopital rules can be applied to either 0 by 0 or infinity by infinity. Even for other questions also, the very, the simplified manner, by which you solve any question, you have to convert the form into infinity or 0 by 0 form only. Or maybe infinity by infinity form. Then only, those factors, those terms, they get cancelled out from the numerator and denominator. Then you see getting a finite value of the limit. Otherwise, you get stuck. So try understanding, try seeing the way I converted all these form into what? 0 by 0 form, and you would also have to do the same. Okay guys, please learn it. Even your standard limits, they'll be like of this form only. Here, let's move ahead. Let's talk about what is this sandwich theorem is. So sandwich theorem is like, let's say there are three functions: f of x, another one is g of x, and third one is what? H of x. Now they are having one particular relation, that your g of x will always be in between h of x and f of x. Okay, so this is the relation. Now tell me one thing. Now just imagine if they are heading towards a point. Now this, hang on. So this specific relation is there, let's say in an interval where x is what? For all x, where x belongs to what? A to b. Okay. Now in this interval, they are having this relation, what I just explained. Your h of x is on, it is on top. Then we have g of x. I'll use different color, let's say, for g of x. What's the yellow color? This is like this. Then we have third one, your f of x. I'll use the red color. Now let's say this is your interval from A to B. Fine. Now this is your f of x, this is your g of x, and this is your h of. Now they are having this particular relation for this interval from A to B. Now just imagine if you come to know if limit, and let's say there is a point C which is between A and C, so x tends to C, where C is somewhere in between, so you get the C belongs to A. This C is what? This where if limit x tends to C for f of x and for h of x, this limit turns out to be the same. Then tell me what will happen. Then obviously, since g of x needs to be always in between f of x and h of x, then this g of x will have to tend towards what? Your L only, right? To the same limit, to the same value, don't you think? Because it needs to meet this constraint. To meet this constraint, it also, then your limit x tends to C for g of x will have to be equal to what? L only. And that's your sandwich theorem. I hope you must have understood now what exactly it means. So it's like there is a particular constraint that your g of x will always be between f of x and h of x, and it is for an interval, let's say A to B. Now in this interval there is a specific value c where your limit of f of x, your limit of h of x, they both are heading towards what? One particular value, that is, let's say L. Then your g of x, which is always in between, which is always in the middle, this will also have to tend toward the same value. Here, so that's your sandwich theorem. Now you would say, where exactly we use it. So sometimes what happens, it becomes very difficult. It becomes very difficult for us to directly calculate your function's limit. Then we use the sandwich theorem. We try to find out two functions where your g of x will always have its value always in between these two functions, and then we try to find the limit of those extreme functions, your f of x and h of x, and if they are also getting the same limit, same value of limit, then your g of x, which the function for which we need to find the limit, which was difficult to solve normally, that would also have the same value. That's how we use it. Sid plays AJ. Sid, this is mathematics for IIT. Clear? Sid, no, nobody. This is not music. So do you hear me singing a song? Now let's talk about a few expansions. And we would be requiring these expansions while solving limits question. Let's say e raised to x. So this is what 1 plus x square upon 2 factorial plus x cube upon 3 factorial plus x raised to 4 upon 4 factorial, and it will continue. Similarly, if you want to find out for e raised to minus x, you can just put x as minus x. So this will become like this. And this will continue. Then we have ln 1 plus x. So how would you write this? X minus x square upon 2 plus x cube upon 3 minus x raised to 4 upon 4, and it will continue. Now just imagine if you replace x as minus x, then it will become minus x square by 2 minus x cube by 3 minus x raised to 4 by 4, and this will continue. For sin x also, sin x is what? X minus x cube upon 3 factorial plus x raised to 5 upon 5 factorial, and that's how it will continue. And for cos x, it is what? 1 minus x square by 2 factorial plus x raised to 4 upon 4 factorial, and it will keep continuing. Even for tan x, if you want to find out what Sid says, sir, what is the derivative of x square? It's 2x. Why? What happens, Sid? You are in which standard? Sid, what do you want to say? Even for your 10x is what? It is x plus x cubed by 3 plus twice of x raised to 5 upon 15 plus, and this is like this here. So these are the few expansions which you can remember, and they are very helpful to calculate limits. Okay guys, so let's move to other thing. Now what is the other thing? Your other thing is, how can we solve a limit? That's the very main question. So the very first way we do it, so let's say if your limit x tends to a for f of x, we have to find it out. So what do we need to do? We always do this thing. The very first thing, we directly substitute x as a. When we substitute x as a, we try to find out the value of f of a. If it turns out to be what? Finite, then well and good. Even undefined also, we say yes, it is heading towards that particular value. Finite or undefined, we got the value of a limit. We are not talking about whether limit would exist or not. We are not talking about. We got the value of limit when x is tending to a. So we just hang on, we just stop here and we say yes, we have solved the limit. Either we'll get finite value or we'll get what? Undefined value. Undefined means what? Infinity. Now just imagine if you are not getting, while substituting, if you're not getting what? Either finite or undefined value, then what would you get? You would get what? Indeterminate forms. What? Indeterminate. And that is where our task starts. Indeterminate forms. The moment you get this indeterminate forms, now there are ways to solve this indeterminate form. Now how? The first way is expansion. We try to expand a few functions and we try to see if we can just cancel out or if we can find the defined or undefined value of limit. Okay, undefined, what I mean to say is infinity or some finite value. And factorization. And when exactly we use factorization? When we have, let's say when we are having a fraction and some factor is there which is making the numerator and denominator both equal to 0 or both infinity, and if we can cancel them out, then we use factorization. When can we use rationalization? So rationalization is specifically used when we see square root terms, either in numerator or denominator, and we try to remove this square root. Then we can use rationalization. Clear? Now just imagine if you are having this sort of question where limit is x tending to infinity and we are having what? Higher order terms, higher degree terms of x. Then what we can do? We can just take x raised to highest degree common both from numerator and denominator, and we can just convert all the remaining terms which are having what? 1 upon x or maybe 1 upon x raised to more powers, they'll turn up to 0. Don't worry, we'll be talking about them. What I'm trying to say is, if let's say we are having this sort of term, this, now if I apply the limit, what will happen? 1 upon infinity, this would automatically would go to 0, it would vanish. So that's what I play, that's what I want to do while solving the limit. Sometimes I need to just cancel out those terms. So that's how I try to solve it. Now let's talk about the exponent forms. So in exponent forms, if we substitute and we are getting, let's say, 1 raised to infinity, 0 raised to 0 or infinity raised to 0 sort of thing, the very first thing what we need to do is we need to take log on both sides. Let's say L is equal to limit x tends to 0 and this is what f of x, g of x. And when you directly substitute x as 0, you are getting, let's say, 1 raised to infinity. Then how would we solve it? The very first thing what you need to do is you need to first take the log on both the sides. So this becomes what? Log of L, and this is what? Equal to g of x into log of x, and your limit is x tends to 0. Clear? So that's what you see, and then you try solving it. Whatever indeterminate form you get, you try to again use expansion, factorization, rationalization, or you can take 1 upon x common or highest degree term in x, you can take that common, and then we have standard limits. Now these standard limits, I'll show you their derivations maybe in next class, but not now, because in today's lecture I would request you guys to just avoid these two, standard limits and L'Hopital rule. Just avoid. I'll explain you what exactly these rules are, but I would say let's avoid these rules. I would be just using these rules or using these techniques or ways in the next class. But before that, I want you to build some manipulating skills, because when those skills are there, you could solve questions very easily when you plan to use L'Hopital or standard limits. Because in that case, what happens? Your speed goes exponentially up, and that's what I want you to have, instead of directly being dependent upon standard limits and L'Hopital rule. Here, so I'll share what are these standard limits. So basically, what we try to do in this technique is, when I explained you the process, the limits property, I was telling you, if you remember, that f of x, g of x, let's say this function is given to you, or maybe division is given to you like this. So what you try to do is, or maybe addition or subtraction, what you try to do is, you try to make any of these function and convert that into a standard limit, and you can directly put its value instead of solving it with the other function. So what I mean to say is, you can convert, let's say this is x tends to a. See, finding this limit is very easy, but if you can just convert this g of x, and you can convert this g of x like a standard limit, and when you can convert this into a standard limit function sort of thing, you can directly put its value instead of just solving it using expansion, factorization. So you can just skip multiple steps. So that is the benefit of remembering or using standard limits. You can directly put its value. Let's say the value is for, let's say, m. Then this question would be what? M into whatever the limit you get here. Limit of f of x when x is tending to a. Let's say this is turning out to be what? L. Directly you can write the answer peacefully. Now what is this L'Hopital rule? Now this L'Hopital rule is only applied when you substitute. So first step is when you substitute whether x is equal to a, you get what? Indeterminate form. When you get indeterminate form, and what sort of indeterminate form? Only two types of form, 0 by 0, infinity by infinity. Then only you can apply this L'Hopital rule. Then what you can do is, you can start differentiating the numerator and denominator separately. Let's say f of dash is g dash x. You can differentiate, and then again you can substitute x is equal to a. If you get finite or defined value, then yes, your limit is solved. If not, again indeterminate form, again those two forms, 0 by 0, infinity by infinity. Then again apply the L'Hopital rule. What is that L'Hopital rule? You have to differentiate numerator and denominator separately. Clear? Is it clear with everyone? Fine. Perfect. Now we can start solving the questions. Okay. So now just let's look at this question. Now what is this question? We have to find the limit x tends to 0, and we have to find the value of this limit. Now how can we find the value of this limit? Okay, so what we can do is, the very first thing is, we'll substitute the limit. Put x is equal to 0. The moment you put x is equal to 0, what you see is it becomes 0 into 0 minus 0 into 0 upon 1 minus 1 whole square. Basically you are getting what? 0 by 0 form, right? What it is indeterminate form. Now what are options we have? We have expansion, we have factorization, we also have rationalization, we also have 1 upon x thing also. But 1 upon x thing is only applicable when limit is tending to infinity, right? You also have L'Hopital and standard limit. So right now we will not be thinking about L'Hopital and standard limit. Let's choose the option from expansion, and then you have factorization, then you have what? Rationalization. So obviously rationalization, no point, because no square root term is there, so this is also cancelled out. Now let's talk about expansion and factorization. Do you really think I should go with factorization? I say no. I'll tell you the reason. Because it is the multiplication of algebraic and trigonometric. So I think factorization is not possible. Had it been completely algebraic function, I would have gone ahead with factorization. So this is also cancelled out. So I would be going ahead with what? Expansion. Now since I have chosen to go ahead with expansion, so I should know what is the expansion of 10 of 2x. Now tell me, what is the expansion of 10 of 2x? So limit x tends to 0, x into expansion of this is what, x plus x cubed by 3. So x cubed by 3 is what? Your 8x cubed by 3, then plus twice of 2x raised to 5, right? So that's a, and we have more terms also. Right now I'll not be writing other terms because those are higher order terms. Let it be. Now 2x minus again expansion x plus x cubed by 3 plus twice of x raised to 5 by 15, and it will keep going on. Fine. Now divided by what? Divided by 1 minus cos of twice of x squared. Now what I can do is I can also expand this cos of 2x. So let's expand, because since I know the expansion of cos, so it's better I should expand it. So let's, so the expansion of cos of 2x is what? 1 minus, now this will become plus, already minus is outside, x square, so 2x square upon twice of factorial, and minus x raised to 4 twice of this 4 upon 4 factorial, and again so on and so forth whole square. Now 1 will cancel out. Now this is what? X into 2x, 2x into x. So this term will also cancel out. So let's cancel these term out. When I cancel these term out here, so now what I see is, if you just look at the numerator, the minimum degree term is what? X raised to 4, correct? Even from the your denominator also, it is x raised to 4. Now you would say how? See, this is x raised to square, x raised to 2, and when you will be taking this x square out from the perfect square, it will become what? X raised to 4. So let's do one thing. Let's take the x square common, both from numerator and denominator. So here I'll have what? 8 by 3 plus 2 into 2 raised to 5 x. I have taken what? X cube common from here. So this will become what? X square. 50. Continue. Even from this also, when I have taken common, so this is what? So this is your 2 by 3. Then I again minus of again twice of 2 by 15 x square, and keep continuing. And then I'll have what? Then I'll have this. Here, when I'll be taking x square or x raised to 4 common, so I'll have what? This is 4 by 2, correct? And then minus, here I'll have 2 raised to 4 upon 4 factorial. 2, when I have taken x square common, so x square will be here. Then perfect square. Okay. Now see, this x square will cancel out. The moment I cancel these x square, x raised to 4, the moment I cancel this x raised to 4, what do I see? Try substituting the value of x as 0 here, this limit. What you see is, this term is vanishing, this term is vanishing, okay, this term is vanishing, and what I'm getting a finite value. Now what is this value? And this will be what? Your value of limit 8 by 3 minus 2 by 3 upon 2 whole square. Okay, what it is your 6 by 3 upon 4 with 2, and 2 by 4 is what? 1 by 2. So what is the correct answer here? C. C is your correct answer. I hope you guys have understood the question. It's a very easy sum, but it is, it is making sure that you better use expansion, and you should also understand which option, which way to exclude, which one to use. Now, why I'm insisting on these approaches? The main reason is because sometimes what happens, the moment I'll share the L'Hopital rule or maybe standard limit thing, you would go so blind that the moment you will see the question, you will blindly start using the L'Hopital rule. And sometimes when we use L'Hopital rule, the question becomes very lengthy, because even see differentiating things, it is not always easy. you get very lengthy terms. And why to have lengthy terms when you can just use your brain and you can just simplify the question? You can solve it in 1 or 2 steps. That's why I want you to just have this sort of approach. First, build this approach, then you can just obviously get the benefit of L'Hopital rule. Wherever you can just save time, go ahead, use L'Hopital rule. I would not say no. Okay, let's move ahead. Let's talk about another question. Now see, look at this question. When you see this question, what do you see? This is x tends to infinity. Let's substitute first. The moment you substitute, what do you see? Infinity minus infinity. This is again indeterminate form. So now what to do? The very first thing is how to solve it. So what are the options we have? First option we can take, yes, obviously x square common. If you feel like you can take it common right away, take it. The moment you take it right now, what do you see is limit x tends to infinity. Take 1 upon x, let's say 1 upon x common. So when you take 1 upon x common from the entire function, it becomes what? Root of a square plus a by x plus 1 upon x square minus a square plus 1 upon x. Now apply the limit, and you would see it is like a square minus a square. So root of a square minus a. So now it has become what? It has become like, I have taken x common, so x will come here. So, my bad. So now when I have taken x common, so I'll have what? This is 0, this will give me what? 0, and this is what? Infinity. So it is giving what? Infinity into 0 form. Now what I can do? Tell me. Since it's square root, as you can see, we can go for rationalization, right? Let's go for rationalization. So for rationalization, what to do? We multiply and divide with the conjugate of this function. Let's do it. X. So this will become what? A square plus a by x plus 1 upon x square minus a square minus 1 upon x square. And in denominator, what do we have? We have square root of a square plus a by x plus 1 square minus a square plus 1 upon x square. Clear? Now, as you can see, this will cancel out with this. This will be cancelled out with this. So now what do I have? I have this a by x, only this a by x remaining. So this x will cancel out. So now what do I have? I have limit x tends to infinity a by root of a square plus a by x plus 1 x square plus root of a square plus 1 upon x square. Now this is what is left. Now let's substitute the limit. So you see this is turning to be 0, this is also 0, this is also 0. So in denominator, what do we have? We have only root of a, so this is a plus root of a, again a, and numerator we already have a. So what it is 1 upon 2. So limit is what? 1 upon 2. So this is the way you can solve the limit. See, I have not done anything exception. Whatever I stated to you, I am applying, and that's how my thought process is. I see the question with a process, with a technique, instead of just using haywire approach. Because when we have multiple thoughts in our mind, we'll never be able to solve a question. Just stick to this concept. This is a very genuine funda, very genuine information I'm sharing with you guys. Even if you want, you can solve it the other way around also. I can tell you the way. You can first rationalize. You can cancel out a square x square and 1 initially in the beginning. Then you have a of x there in the numerator, and then you can just take x common both from numerator and denominator, and x will cancel out, and you get the same term. Okay, let's move to our next question. And here is this question. Now look at this question, and I have seen people talking about these questions, and they keep coming to me and they just keep asking this question. Sir, whenever we get summation sort of question or maybe pi sort of question, we don't know how to solve it. Now I'll tell you the way, I'll tell you the process how to solve these questions. So in these questions, the very basic information is, first, either it is pi something or summation something. First, you have to simplify it and get the term in terms of n. This is a very basic information or very basic step you need to do always. Otherwise, you can't be able to apply the limit. So that's what you have to just keep this in mind. If you can't do this, you can't solve the limit. So let's look at this question. So what it says, Pn is equal to what? It is S2 into this. So let's do one thing. Let's find out. Let's find out first Sn minus 1. So what it is going to be n into n plus 1 by 2. This is what? N plus 1 and 2 here, then yes, go up to cancel out. Finally, what do I have? N into n plus 1 upon I have n square plus n minus 2. I can factorize this. Plus 2 minus 1, so n minus 1. So that's how I can factorize it. Clear? Is it clear with everyone? Okay. Now, this is what? This is any term. So this is your Pn is what? Pi of starting from let's say you're starting from 2 to, let's say we're going till n. So let's make it, instead of making n, let's write it r here. This is n into n plus 1, n plus 2, n minus 2. Now see, when I look at this, what do I feel? See, the very first thing what I feel is, it's like, look at this term and look at this term. These two fractions, n minus 1, and look at this, n plus 1 into n plus 2. Don't you think when we will be writing fractions like in multiplication, sometimes when I'm getting 1 here, or maybe not 1, let's say sometimes when I'm getting 2 here, earlier in the earlier term I'll be getting 2 in the numerator, or maybe right now, let's say if I'm having 3, n is equal to 3 here, so 3 by 2. Now go for next term, n is equal to 4, so I'll have 4 here, but your denominator will have 4 minus 1, 3. So you'll have the previous term. So if you see this, so basically your terms, your denominator numerator will have pairs, they'll get cancelled out. Same goes with here also, because there is a difference of only 1, correct? So many terms will cancel out. So let's use it. And that's what I wanted to share this with you guys, that you would be seeing many terms getting cancelled out and you will be having answer in simplified terms of n. Then you go ahead and apply your limits. Let's use it here. When I put start from n is equal to n greater equal to 2. So let's put it here. So when I put 2 here, so 2 upon 1, then 3 upon 2, then again you have 4 upon 3, and keep continuing till n upon n minus 1 here. Similarly, for this also same thing, 3 upon 4, 4 upon 5, when you put 4, so it becomes 5 upon 6, and this will continue till this. Here, now see, this will cancel out, this will cancel out, so everything will cancel out, even your n minus 1 also. So from the beginning, from here, what will you get? You get n and this only first denominator left for you, correct? And from here, what you see is these terms. So your n plus 1 will also cancel out. So you'll have 3 upon n plus 2 remaining, correct? Now this is your Pn. Let's apply the limit now. N tends to infinity. This is 3n upon n plus 2. Clear? Now when I put the limit, it becomes what? Infinity upon infinity form, indeterminate form. Now when our limit is heading towards infinity, what is the way I have shared with you? Form 1 upon x sort of terms. When you form 1 upon x sort of terms, what do you see? Take n common, so you get what? 3. And here you get what? 1 upon 2 by n. When you apply this limit, what do you get? 3. That's it. Sorted. Easy question. Right? Okay. Let's move to our next question. And with every question, we'll try to just increase our knowledge bank. We would be observing every single question closely, so that in future, if we get new question, we should be able to find the exact way to solve this. Now look at this question. Limit n tends to infinity. Now here is what you can see. Again, there is a series and you have to find. But before that, what I need from you is first simplify it. Now just look at this. How can you simplify it? The very first thing which I observed is, can I make pairs like this? If I try to make the pairs, so there are two options. Either I should have an even number or odd number. Yes or no? Yes. So let's say when I have even number. So obviously when even number is there, so I'll have exact same number of, I'll have pairs. Every number will be there in the pair. So limit n tends to infinity. What do I have? See, this is what a square minus b square. It is looking like a square minus b square, right? So I can write it like 1 minus 2, then 1 plus 2. And this has 3 minus 4 into 3 plus 4. And this will continue till your last pair. Your last pair will be what? With n minus 1 whole square minus n square, right? So how will I write? Like this. Correct? And this is upon n square. Now I can take minus 1 common easily. Let's take minus 1 common. So what do I have left now? Minus 1 common. So 1 plus 2 plus 3 plus 4 until n minus 1 and plus n. So if I just sum it up, what do I get? Limit n tends to infinity minus n into n plus 1 by 2 n square. N will cancel out. Again infinity, let's put n tends to infinity. What do I get? Infinity upon infinity, indeterminate form. So what do I need to do? I need to just make it 1 by n. So how can I make it when I'll be taking n common? So let's take it minus, if I take common 1 by n common, so what do I have? 1 plus 1 by n, and here 2. Here. Now let's put in limit, what do I get? Minus 1 by 2. So minus 1 by 2 is there when n is your even. Now just imagine if I'm not having pairs. So when I'm having odd terms. So now tell me one thing. Till which term I'll be having pairs? Obviously till n minus 1, because nth term is what? That is the odd term. Here. So how will I be writing it? I'll be writing it like this. Minus 1 obviously common, starting from 1, 2, 3 till where? Till n minus 2 and n minus 1. Here, and this will be what? Your numerator will have n square again separately common upon what? N square. Here. Now this can be written as n tends to infinity minus n minus 1, then n upon 2 plus n square upon n square. Apply limit. What it is? It is infinity upon infinity square, like this. Infinity minus infinity upon infinity. Solve it. It would become what? It would become as if it is infinity minus infinity. What you can do is, again it is an indeterminate form. What I would suggest is it would turn into 0 by 0 form for sure. Since it's infinity, so what we can do is we can take n square common. Let's do that. Let's take n square common. So it would become what? N tends to infinity minus 1 by n first, then 1 n common, so let's it. This is divided by 2 plus n square common, so it becomes 1 upon n square common from the denominator also, so that will cancel out. So n square, this will cancel out from here, n I took common and this correct. Now apply the limit. What do I get? I get minus half plus 1 upon 1. Whereas when this is odd, when n is odd, I get what? Half. Here, so as you can see, the moment I change the odd even terms, my answer changes, my limit changes, and that's the beauty. And I want all of you to just just remember all these things when you're solving questions. Here, does anyone have any doubt? No? Fine, let's move ahead. Okay, again, summation sort of question. Now, how would you solve this question? It's a very easy question. See, your denominator is same as it is. So it's all about, if you take the LCM also, how would you see it? You would see 1 minus n square, and starting from 1, 2, and it is going till n. So let's write the summation of all the natural numbers there in the numerator. So this will be what? N into n plus 1 by 2. And you can expand it. You can just factorize it. 1 minus n and 1 plus n. This will cancel out. So finally, what do we have? N by 2, 1 minus n. Now you apply the limit. Limit n tends to infinity. This is your original function. Here, now apply limit. It is becoming what? Infinity by infinity. Correct. So what you can do, guys? You can just take n common. The moment you take n common, you make it about 1 by n sort of thing. 2, 1 by n minus 1. Here. Is it clear with everyone? Now apply limit. This becomes what? 0. So I have what? Minus half. This is my limit. That's the answer. B. Correct. Simple. You do not need to get scared of all these questions. These are very simple questions, because when I was teaching on JEE Quest, I found maybe 1 or 2 guys, they were just complaining about these questions. Sir, when we have pi or summation sort of questions, we find difficulty to solve them. The difficulty is while simplifying them, not when applying the limits. It's all about simplifying, which they don't do. And I request all of you to just simplify, try simplifying. That's the first step. Then other things are remain easy. Applying limit is very easy. Here, let's move to our next question. Limit x tends to 1. Here it is written what? Starting from 1, we have x terms. Starting from x, and it is going to x raised to 100 minus 100 upon x minus 1. See, when I look at this term, this sort of thing, the very first thing which comes to my mind is that since all algebraic, see, expression is algebraic, when everything is algebraic, and when I'm just checking the limit by substituting, what am I getting? 0 by 0 in indeterminate form. The very first thing which clicks my mind is algebraic approach. Algebraic means your factorization. How can I factorize this? And the way I factorize it, I should get this one, x minus 1 as one of the factors, so that I can cancel it out with both numerator and denominator. So what I can do? What I can do is, why not just split this 100 into 100 times, like this, 100 times. Let's do it. When you do it and join them with these x, because we have x terms, 100 x terms are there. Correct, guys? Now, let's take x minus 1 common from each and every term. Now tell me, when you take common x minus 1 from each term, from here, this is easy, you get this one. Even from cubic also, you remember. What about this fourth? What about fifth one? This term. What about 100 term? What will you get? Do you have any idea? Any guesses? I'll tell you. It's always easy to remember. Whenever you have this sort of expansion, x raised to n minus 1 and you're dividing it by x minus 1, you always get this term 1 plus x square, and it is going till x raised to n minus 1. Always. If you don't believe, you can just multiply this term with what? 1 minus x. You can multiply it. Check. Because see, when everything will be multiplied with x, this first one, you will get as it is, the same thing, correct? Till x n minus 1, correct? The moment you multiply with x, the terms would start from the next. You will skip this term. You will not have 1 for sure. And you will have these terms till what? This is x raised to n minus 1. This will go till x raised to minus n. Every term you will find the negative and positive. Only for the first and last term. These terms will be remaining, correct? You can, this is x minus 1. Sorry guys, x minus 1. Multiply with x minus 1. That's my mistake. I multiplied with 1 minus x. Okay. So you can just try this out. So how will you write it? So since it is x raised to 4 minus 1. So how will you write it? Starting from 1 x till when? Till x cube. And for this 100, what will you do? Start from x raised to 99 and go till last to 1. That's it. Now apply the limit. This becomes 1. This becomes what? 1 plus 1, 2. This becomes what? 3. This becomes next 4. And it is going till, for 100, how many terms? Starting from 1, going till 99 power, x raised to 0 to x raised to 99. How many terms? 100 terms. So 100. Let's add natural sum. What it is? It is 100 into 101 divided by 2. So what do you get? 50, 50. That's it. Done. Simple question. Right? Let's move to another question. Now, in this, there are two limits. X tends to 0, y tends to 0. And right now, you are not moving along the x-axis. You are moving along the curve. And the curve is what? X is equal to y square. You are moving along this curve. So we have to calculate the value of this limit. So how can we calculate? The best approach to solve this question is, why not we replace your y in this function in terms of x. You can do it. So y square is what? X. So put it here, x. This is sin x upon x square plus sin y square will be what? Sin x. Now how does it look like? First substitute the limit. You are getting what? 0 by 0 form. The best thing what you can do is, since you have options like rationalization, factorization or expansion. Obviously rationalization is not possible because square root terms are not there. Even a factorization is not possible. Why? Because, what is the problem with this? Because you don't have the algebraic sum of, correct? Not algebraic expansion. Algebraic terms are not there. It is mixture of algebraic and trigonometric. So the best way is expansion. So why don't we expand it? Let's do the expansion of your sin x. So x plus x minus x cubed by 3 factorial plus x raised to 5 by 5 factorial, and then we have higher order terms. X square plus x minus x cubed by 3 factorial. Then we have x raised to 5 upon 5 factorial, and click continue. Now what we can do is, we can take x common easily. The moment we take x common, so it becomes what? Limit x tends to 0. Twice of x is common, minus of x square by 3 factorial plus x raised to 4 upon 5 factorial, and click continue upon x common. So what do we have? 1 plus x minus x square by 3 factorial and 4 by 5. This will continue. Now apply the limit. X will cancel out. Now substitute the limit. It becomes 0, 0, 0, 0. Only we'll have what? 2. You see the answer. That's it. Done. Simple question. Right? Let's move to another question. 1 minus cos mx upon 1 minus cos nx. Since it's trigonometric, better way is to use the expansion. So let's use expansion. limit x tends to 0. But before that, I always recommend you guys to just check the limit. Substitute x is equal to 0. What are you getting? 1 minus 1, 0 upon 1 minus 1, 0. 0 upon 0, indeterminate form. So now expand the limit. Now expand, because so 1 minus, it will become plus because already minus is here. Then x square. So instead of x we have mx. Mx square by 2 factorial minus of x into m raised to 4 upon 4 factorial. And then we have higher order terms on 1 minus 1 plus nx square by 2 factorial minus x whole raised to 4 factorial, and this will continue. You can just cancel 1 here. Now substitute. The moment you substitute, you are getting what? 0 by 0. But what you can do is you can take x square common. Let's take x square common. So what do we have now? X square n square upon 2 factorial minus x square n raised to 4 upon 4 factorial, and this will continue. X square will cancel out. So finally, what do we have? Limit x tends to 0. This. Now we can simply put this, substitute x is equal to 0. Let's substitute. What are we getting? Every term which is having x term, which is having x power of something of some power of x, that will vanish, and this will be what? M square upon 2 factorial. 2 factorial. Final answer would be what? M square by n square. That's it. Great. Sorted. Let's move to our next question. Oh, we have this question. Now tell me one thing. How would you like to solve this? Because first I would request you to just put your substitute x is equal to 0. You get 1 minus 1 minus 1 plus 1 upon 2 cos x plus 7. So this is 1. So basically 9. So this is what? 3. 3 minus 3. Oh, so basically again 0 by 0 indeterminate form. So now tell me, how would you try to solve this? Obviously rationalization is there because the square root term is there, correct? And apart from that, not possible the factorization. Factorization 3, 4 multiplied. We can use actually factorization, and we can use expansion also. Both are possible in this. Now you would say, why sir? I'll tell you the reason. The reason is very simple. See, this is what? Exponential form. So we know the expansion. Even if you take, let's say 3 raised to, or let's say 4 raised to x common from this, you will get 1 minus 3 raised to x. So you can factorize also. So we have both the options. So let's do one thing. First start with rationalization. How can we rationalize it? Since we want to remove this square root term, so we have to multiply with this plus. We have to multiply with the root of 2 cos x plus 7 plus 3. So let's multiply. 1 minus 3 raised to x minus 4 raised to x plus 12 raised to x upon twice of cos x plus 7 minus 9. This will be what? 2 cos x plus 7 plus of 3. And this becomes what? Minus 2. So I'll just simplify it and directly write it to save space for our calculations. Okay. 7 minus 9 is what? Minus 2. Directly writing it. Now try putting the limit 0 again, because it is what? 2 minus 2, 0 here, and again our numerator also 0 minus 0. 0 upon 0, again indeterminate form. So let's try to factorize this. So what do I have now? Limit x tends to 1 minus 3x common. Then from this also what I can do is I can take 3 raised to x common. So what do I have? I have So 4 raised to x, I can take common. So I have 1 left minus. This 12 raised to x can be written as what? 3 raised to x into 4 raised to x. X can be taken as common. So 3 into 4. Simple. Got it? So I can write it like this. So just to save again my space, I'll directly write this in terms of factors. See, expansion is also possible. You can expand 3 raised to x, 4 raised to x, and 12 raised to x. You can expand. There is no problem with that. So I'll be taking common. So I have what? Cos of x minus. Okay. Now what I can do is, let's go for the expansion. Let's expand 3 raised to x and let's expand 4 raised to x also, and even cos x also. Let's do this. When we try to expand, what do I see? What is the expansion of 1 raised to x? Because I told you e raised to x only. So 1 plus x square by 2 factorial like this, correct? Now here what I want from you guys is, it is what? 3 raised to x. Since I have not told you, now you would say, no sir, we don't remember, you have not told us. So how to do it? You can use your log properties. Now how? I'll tell you. E raised to log of e 3 raised to x. Now x can come to the forward, so it will be what? E raised to x into log of e3. Now instead of x, you are having x into some constant. You use it, simple. So 1 minus x log e3 minus x log e3 whole square by 2 factorial, and we have higher order terms also, so I am not writing it right now. Okay. 1 minus x into log of 4 minus x into log of 4 whole square by 2 factorial, and again higher order terms, I am writing it. Do I need to expand this? No, because I am getting finite value. So let's not expand this. Let it be as it is. Twice of cos of x plus 7 plus 3. And divided by, we have twice as it is. Cos x is what? 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial. Not writing the higher order terms, minus of 1. Here. Now see, 1 will cancel out, 1 will cancel out here, and so what do I have in the numerator? Before doing it, what I can do is, I can take x common from here, x common from here. Let's take x common and this minus 1 also common. So when I take x common from both the terms, I'll have x square here. And shall I take minus common? Let's not take it. I'll tell you why. So I'll have log 3 here, minus of x log of e3 whole square by 2 factorial, and this will continue. Then again minus of log of e4 minus of x into log of e4 whole square upon 2 factorial, and this will continue, and this is as it is, twice of x, 7 plus of 3 upon x square common. So what do I have? Minus of 1 upon 2 factorial plus x square by 4 factorial like this. Okay. Now x square will cancel out here. Now substitute. When you try to substitute, what do you see? This is going to be 0, this is going to be 0. So I have what? Minus of log 3, minus of log 4. So when I multiply them, so they become what? Log of 3 into log of 4 okay, and minus, and here what am I having? Minus of 2 From here, what exactly I'm having here? From here, I'm having what? 0 the moment I put 0, so this will become what? Twice 2 plus this 3 plus 3, 6. This 6 is going up, so I'm getting what? Minus of 12 log of 3 into log of 4. Now just think, can we simplify this also? 1 minus 3 common, so 1 minus 4x, correct? Yeah, I forgot one thing. The 2 is here. 2 I forgot here. This 2 is already here. 2 is already here. So 2 will cancel out. So I'll have what? Minus 1. Minus 1 and this minus 6. This remains as minus 6. This remains as minus 6. Now, look at the base. Base is same. So what we can do with this? Any idea, guys? Come on, guys. Can we do anything with this? What I can do is I can take 2 square out. So log e2, log e2. Let's leave it as it is. Okay. Shall we move to our next question then? Fine. Let's move to our next question. Okay. Let's find out this limit. This is sine e raised to x minus 2 minus 1 upon log of x minus 2. Now put the limit x as 2. So I am getting what? Sine e raised to what? 2 minus 2. So it becomes what? 0. So e raised to 0 is what? 1. 1 minus 1, 0. So sine of 0 upon log of 1. This is also 0. So 0 upon 0. Again, indeterminate form. So what we can do? Sine is there, log is there. Which is a better option? Expansion? Fine. So let's go ahead with the expansion. So what we can see, we know the expansion of 1 plus x and 1 minus x. So think about what you can exactly expand. So let's do one thing. X minus 2. Let's do one thing. First, why don't we write, see if I take the limit, this is what x tends to 0. That means if I talk about x minus 2, so this x minus 2 would tends to 0. If I take this to left hand side, then x minus 2 will tends to what? 0. Let's put it. The limit x minus 2 tends to 0. Sine e raised to x minus 2 minus 1 upon what? Log of x minus 1. Correct? Now let's put x minus 2 as t. When I put it x minus 2 as t, what do I see? I see limit t tends to 0 sine of e raised to t minus 1 upon what it is. This can be written as ln or log. X will be written as t plus 2 minus of 1. Correct? And this will become what? Limit t tends to 0 sine of e t minus 1 upon log of t plus 1. Correct? Now yes, now expansion is easier for me. Correct? Let's expand it. The limit t tends to 0 sine of 1 minus 1 plus t square by 2 factorial plus t 2 by 3 factorial and t continue, and here I have minus 1 upon log expansion is what? T minus t square by 2 plus t cube by 3 and continue. So I have 1 will cancel out, so I have inside only t. Now this is what sine of something. Now first put t is equal to 0. So what do I get? I get again 0 by 0 thing. What to do? Do I have to expand sine also? Okay, let's expand sine also. See, this question can be solved using standard limit very easily. Very easily. Yeah, I'm telling you. You can solve it peacefully. So now, like earlier, this used to be what x. And then we used to write, while expanding, going for sine's expansion, what we used to do? First we used to write x, then minus x cube upon 3 factorial. So what I'll do is, I'll just write this term. I'll not write its higher order term. Why I'm saying, I'll tell you the reason. Minus, it will be what? It will be square. Obviously that will give you more, no, higher order powers. And cube by 3 factorial like this. And plus, and upon what? Same thing. Now what I can do is here, I can, if you just put the limit, what do you see? 0 upon 0. But what I can do is, I can take t common. The moment I take t common, both from numerator and denominator, see, this will become 1, this will become 1. So t common from every term. And I apply the limit. After taking t as common, and if I apply the limit, see, this term will vanish, this term will vanish, all the terms will vanish. What I'll have is, I'll only have 1 here in the numerator here upon 1 minus t by 2, all the term will vanish, only 1 will remain. So the final limit will be what? 1. Those who can't read it, I'm writing it here. Final limit will be what? 1 only. It's a very good question. See, this can be solved using your standard limits very easily. But it's just, I wanted to give you hands-on experience in expansion and factorization, rationalization, so that you can just solve these sort of questions. If at all you're not, your mind is not finding any standard limits, or not, let's say L'Hopital rule. Using L'Hopital rule also you can solve it quickly. In 1 or 2 steps, that's it. And that's it. So my lecture is over. Thank you guys. So in next session we'll be talking about what? I'll be talking about your L'Hopital rule, standard limits. We'll also be talking about continuity as well. Okay. So that's it, guys. I would like to thank Cengage Book for the questions, and I would like to inform you regarding my Fun Day series also. I'm conducting a Fun Day series on Unacademy application. So if you want to attend any of my session on Unacademy application, what you need to do is first install Unacademy application. The moment you install it, follow my profile, just search for it, Nishant Khanduja, and then you will be seeing all my lectures. Just go for any lecture, you can watch my lectures there. And if you want to attend live session, those live sessions are what? Free live sessions. What? Free live sessions. So for that, what you need to do is, to attend my free live session, you guys need to simply click on my videos, okay, and it would ask for a promo code. Just apply this NK001. This will give you access to watch my videos free of cost. Here, and thanks a lot. And please subscribe this channel. Let's Crack JEE English. If you want to watch my videos on live videos in future also, and those who have planned to join Plus and Iconic subscription, they can also use my code NK001, and you can just hit the bell icon button so that you keep getting notification for new videos. And yes, regarding my live session, free special class, if you want to attend right now, so there is one session that is going to happen at 10 o'clock tonight, where on the Unacademy application, so you can just install it right now. And what are we going to discuss there? We'll be solving problems on application of derivative. So you can come and solve problems with me on application of derivative, guys. So we'll be waiting for you on Unacademy application. So come there and just follow my profile and punch that code NK001. that will give you an access to watch my live session free of cost. I'm saying it again. If you are not going to punch my promo code, you are not going to watch my videos free of cost. So please punch it, NK001. Clear? Bye bye. We'll be seeing you at 10 on Unacademy application.